In this video, we're going to talk about geometric series. Before we do that, let's talk about geometric sequence. Take a look at this sequence. What do you notice? How do you get 3 from 1? And how do you get 9 from 3 and so forth? Well, you have to multiply 3 to 1 to get 3. And 3 times 3 will be 9. And 3 times 9 will be 27. So basically, you keep multiplying 3 to a term to get the next term. And we have a common ratio here, which is 3. What about this sequence? How do you get 9 from 27, 3 from 9, 1 from 3, and so forth? You have to keep multiplying by 1 over 3. That is the common ratio. So geometric sequence will have a common ratio. And you keep multiplying common ratio to a term to get to the next term. What about this geometric sequence? What will be the common ratio of this geometric sequence? It will be -2. Because you have to multiply -2 to -1 to get +2. -2 times 2 will be -4. -2 times -4 is +8, and so forth. So all these three are examples of geometric sequence. The sum Sn of the first n terms of an infinite series is called a partial sum. The partial sum of an infinite series may approach a limiting value. Consider this infinite series. By the way, this is a infinite geometric series because the common ratio is 1 over 2. Now, what will be S1? That is a partial sum when you only add the first term, which is just 1 over 2. What about partial sum of 2? S2. That is when you add the first two terms, which is 1 over 2 plus 1 over 4. And that is 0.75. What about S3? That's when you add the first three terms. So you get 1 over 2 plus 1 over 4 plus 1 over 8, which is approximately 0.88. What about S4? That's going to be adding the sum, finding the sum of first 4 terms. So 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16, which is approximately 0.94. What about S of 5? That's the partial sum of adding the first 5 terms. So 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32, which is approximately 0.97. So it looks like as you add more terms, like find the partial sum of S of 6, S of 7, and so forth, it looks like you're getting closer to 1. When we talk about infinite geometric series, again, we're talking about infinite geometric series. There is a way to find the sum of an infinite geometric series. That is, the sum of an infinite geometric series with first term a of 1. A of 1 is the first term of the series, and common ratio R is given by a of 1 over 1 minus R. That will be the sum of infinite geometric series. But there's a condition, provided only when absolute value of R is less than 1. If absolute value of R is greater than or equal to 1, then the series has no sum. And we're going to take a look at some examples. By the way, what about finite geometric series? Well, if the series is finite, that means there are limited terms. Therefore, you could easily find the sum of finite geometric series. So let's go back to this example. Will this infinite geometric series will have a sum? Well, what is the first term? First term is 1 over 2. What is the common ratio? Common ratio is 1 over 2. Now, is absolute value of r, is that less than 1? If it does, then we are going to have a sum. Well, it's going to be absolute value of 1 over 2, and that is less than 1. So we are going to have a sum. And what is the sum of this geometric series? It's going to be A1, which is 1 over 2, over 1 minus r. The common mistake is students think this is 1 minus absolute value of r, but it's just 1 minus r, which is 1 over 2, which is going to be 1 over 2 divided by 1 over 2, which is 1. So the sum of this geometric series is 1. Again, remember, this formula only applies to infinite geometric series. What about this geometric series? We know that first term is 1. What about common ratio? What is r? R is going to be 3. And unfortunately, absolute value of 3 is not less than 1. So therefore, this infinite geometric series will not have sum. This means that as you add more terms, the sum will go to infinity. What about this infinite geometric series? What is the first term? First term is 1. What about common ratio? The common ratio will be negative 3 over 4. Now, is absolute value of negative 3 over 4 less than 1? Yes, it is. So this infinite geometric series will have a sum. And how do we find the sum? It will be A1, which is 1, over 1 minus r, which is negative 3 over 4. So you end up getting 1 over 7 over 4, which will be 4 over 7. So this infinite geometry series will have a sum of 4 over 7. Oh, by the way, if the infinite geometric series has a sum, then we say it converges. If it doesn't, then we say it diverges. And take a look at this example. It's hard to see which one is the first term and which one is the common ratio. So what we're going to do is we're going to write out a few terms. So plug in 1, you get 1 minus 1, which is 0. 0.7 to the power of 0 is 1. 1 times 3 is 3. That's the first term. Plus, when I is 2, you are going to get 3 times 0.7. And when I is 3, you're going to get 3 times 0.7 square and so forth. So we wrote first 3 terms. Now, what is the first term? First term is 3. What is the common ratio? Common ratio is 0.7. You keep multiplying 0.7 to get to the next term. Now, is absolute value of 0.7 less than 1? It is. So we are going to have a sum for this infinite geometric series. And what is the sum? It's A1, which is 3, over 1 minus 0.7, which is 3 over 0.3, and that is 10. Therefore, this infinite series will have a sum of 10. We have 0.24, 24, 24, and it's repeating. Is there any way we could simplify this decimal? to a fraction? Well, if you notice, we could rewrite this as 0.24 plus 0.0024 plus 0.000024 and so forth. So this is like an infinite geometric series. What is the first term? First term is 0.24. And what is the common ratio? One way to get common ratio is you divide this second term by the first term, or the third term by the second term. And you'll get 0.01. Now, is absolute value of 0.01 less than 1? It is. So we could find the sum of this infinite geometric series. It will be 0.24 divided by 1 minus 0.01, which is going to be 0.24 divided by 0.99, which is the same thing as 24 over 99. And 3 goes into both of them, so you get 8 over 33. So if you divide 8 by 33, you will get 0.242424 and repeating.